Hello, we're going to begin our discussion today by taking a look at operant conditioning. Please recall in our discussion of classical conditioning, we already considered how classical conditioning occurs when we learn associations between events that are not controlled by the learner, where one event, we could call that a stimulus, is associated with another event, a different stimulus, until eventually both stimuli elicit the same response. Pavlov's dogs salivated to food. When a tone was paired together with the food enough times, the dogs eventually salivated to the tone alone. That's how classical conditioning works. Operant conditioning is another kind of associational learning, but in operant conditioning, the learner comes to associate a behavior or action with a consequence. In operant conditioning, actions are followed by rewards or punishments. When a rewarding event follows an action, it increases the likelihood that the action will occur in the future. However, when a punishing event follows an action, it decreases the likelihood the action will occur in the future. If a child likes to cut up in class and try to make his fellow students laugh, and it works, and they laugh, and he gets attention, that attention, positive attention, would be an example of a rewarding event, and he will probably be more likely to cut up in class in the future. But if that same behavior is followed by punishment, say being kept in the room during recess, he may be less likely to engage in that behavior in the future. That is how operant conditioning works. A psychologist by the name of B.F. Skinner studied operant conditioning. He used animals to gain a better understanding of the principles of this kind of learning. He used rats and he used pigeons, and he was able to teach his animals some rather amazing skills. Like this pigeon, for example, is picking out cancerous cells in this slide by pecking on them in order to get food. Prior to Skinner, another psychologist named E.O. Thorndike explored the relationship between behavior and rewards and punishments. And he developed what's called the law of effect. And as you can see here, basically the law of effect states that rewarded behavior is likely to be repeated. We could also add that punished behavior is not likely to be repeated. So these principles of learning associated with operant conditioning involving rewards and punishments have been found to apply to different kinds of learners, including both humans and animals. In Thorndike's research, he placed a cat inside a box. He called it a puzzle box. And the cat had to figure out how to get out of the box by tripping a latch in order to get food waiting for the cat on the outside of the box. As you can see by looking at this graph, the cat learned fairly quickly how to get out of the box. At first, it took the cat around 240 seconds to make it out of the box. Eventually, the cat was doing it in around 10 to 20 to maybe 30 seconds, as you can see. And it was a gradual decrease in the amount of lapsed time between when the cat was placed in the box and the cat was able to escape from the box, demonstrating that learning took place. And this kind of learning, again, is called operant conditioning because the learner is operating on the environment in order to produce a consequence. When Skinner began studying operant conditioning with animals, he developed a special apparatus that could be used called an operant conditioning chamber, eventually called the Skinner box, named after B.F. Skinner. Here you can see what it looks like. Skinner would teach this rat how to press a bar in order to receive food. He could also introduce sound or light in his studies as well to see if the rat could learn to discriminate different conditions under which to press the bar. For example, he might teach the rat, you can only get food if you press the bar when the light is on. So how would you teach a rat to press a lever to get food? Think about that for a moment. Skinner used a method called shaping. In shaping, you reward all the little behaviors that lead up to the desired behavior. So if Skinner placed a new rat in the box, when the rat turned towards the bar, he would cause a food pellet to drop in that little dish and make a noise, and the rat would go over and get the food. Then the rat would probably explore the Skinner box more, and this time when the rat turns toward the food but also steps closer to it, he would get a reward. And then the next time he has to get even closer before he gets a reward. And the next time even closer, until eventually the rat is all the way over there, stays over there now, and reaches up and is exploring that area, maybe accidentally press the bar, he gets food, and eventually the rat learns that to get food, he has to press that bar. Once that happens, then the response has been learned, and then Skinner was able to study other things like if you don't give the rat food anymore, how long will he press the bar until he stops pressing it? And that, of course, is called extinction. Or when you're teaching the rat to press the bar, once he's pressing it, what if you only gave him food every once in a while, as opposed to giving him food every single time? How would that affect how quickly the rat learned the response and how quickly you could extinguish the response? So this shaping procedure that Skinner used to help the rat to learn the response in the first place turns out to be a very helpful method that can be used to help organisms learn new behavior. Not just animals, but humans also can learn new behaviors through shaping. A great example of this would be teaching a child potty training. When a child is taught how to go potty, they need to learn several little behaviors that lead up to the desired goal behavior. And once they're able to learn these little behaviors that eventually result in the desired goal behavior of going potty, they've been rewarded for these behaviors along the way, then they can connect these behaviors together in order to demonstrate this ability to go potty, for which they are rewarded, increasing the likelihood that they will do it again and again. As it turns out, using operant conditioning, there are actually two different ways to increase behavior. One is to use positive reinforcement. A positive reinforcement is like a reward. So you add a desirable stimulus following an action. If you pet a dog that comes when you call it, the dog will probably be more likely to come in the future. If you pay someone for work done, they'll probably continue to do that kind of work as long as they're getting paid for it. In negative reinforcement, you remove an aversive, that means an unpleasant stimulus, and whatever action you engaged in to remove that unpleasant stimulus, you'll be more likely to do it in the future. So you can see with both positive reinforcement and negative reinforcement, the result is an increase in behavior. An example given here is taking painkillers to end pain. Let's say you have a headache and you take medicine to relieve your headache. Something unpleasant is happening. You have a headache. And when you take medicine and the headache goes away, you'll be more likely to do that in the future. When you get in a car to drive it and you forget to fasten the seatbelt and the car makes a noise, when you fasten your seatbelt, the noise stops. The noise would be an unpleasant stimulus and you are able to stop it by fastening your seatbelt. You can even prevent it by fastening your seatbelt before you start the car. But that would be another example of negative reinforcement. See if you can think of examples of positive reinforcement and negative reinforcement in your own life. If you find yourself having a little difficulty telling the difference between negative reinforcement and punishment, you are not alone. When I took general psychology, this was something that took me a little while to understand. One way to differentiate between negative reinforcement and punishment is to remember that reinforcement, whether it's positive or negative, always results in an increase in behavior, whereas punishment results in a decrease in behavior. Also, when the unpleasant event occurs relative to the behavior occurring, helps us to differentiate between negative reinforcement and punishment. In negative reinforcement, something unpleasant is already happening, and then we do something to make that unpleasant thing stop. Whatever we've done to eliminate the unpleasant stimulus, whatever it happens to be, we'll be more likely to do it in the future. In other words, we're reinforced for that by removing the negative. That's why it's called negative reinforcement. In punishment, the unpleasant event follows the action. Say a child getting a spanking, for example. So the child will hopefully be less likely to engage in the punished behavior in the future. See if you can think of another example of punishment and of negative reinforcement to be able to tell the difference between the two. In operant conditioning, reinforcers can also be primary and they can be conditioned or secondary reinforcers. A primary reinforcer is something that reinforces us naturally without us having to learn it, often satisfying a biological need. So a primary reinforcer could be food. A conditioned or secondary reinforcer gains its reinforcing power by associating it with a primary reinforcer. Money would be an example of a secondary reinforcer. We can't eat money, but we can spend money on food which we can eat. Sometimes we are rewarded or reinforced immediately after we do something. That's called an immediate reinforcer. And sometimes reinforcers are delayed. They occur after some period of time before we actually get the reward. Think about going to college and graduating from college and earning a college diploma. That's a really big deal. It takes a lot of hard work over a period of time in order to accomplish that. So that would be an example of a delayed reward. But in order to help us eventually achieve that accomplishment, we have smaller goals that we accomplish along the way, each of which is rewarded by the accomplishing of it. That helps us eventually to gain the ultimate reward of graduating from college. Reinforcement can also occur either continuously or in a partial or intermittent way. With continuous reinforcement, the learner is rewarded every time a behavior occurs. Where in partial or intermittent reinforcer, the learner is only reinforced some of the time when learning occurs. As it turns out, if the learner is reinforced using continuous reinforcement, they learn a behavior more quickly, but they also extinguish more quickly as well if the reinforcement is removed. When I use the word extinguish, I mean they stop doing the behavior more quickly if the reinforcement is removed. In partial or intermittent reinforcement, the behavior is learned more slowly, but it's also harder to extinguish the behavior if it is learned using a partial reinforcement schedule. Can you think of why that might be the case? That partial reinforcement produces more enduring behavior that's harder to extinguish than does continuous reinforcement. Well, if you're thinking that partial reinforcement would produce more enduring behavior because the learner has come to expect that their behavior is not going to be rewarded every time. So when it's not rewarded at all, in the case of extinction, they're going to do the behavior longer, still anticipating a reward is coming eventually, than if they were reinforced every single time when they were learning the behavior. As it turns out, there are different kinds of partial reinforcement. Partial reinforcement can be based on the number of responses that occur, and that's called ratio. Or partial reinforcement can occur on the basis of the amount of time that's lapsed since the last reinforced behavior, and that's called interval. We can further distinguish between different kinds of schedules of partial reinforcement by considering whether or not the reinforcement occurs after a fixed number of responses or amount of time passed, or a variable number of responses or amount of time passed. There's some good examples given here. If you happen to go to a coffee shop and you have a card and they stamp it, or they keep the information online for you, And after every 10th purchase, you get a free coffee. That would be an example of a fixed ratio schedule. You have to get 10 coffees and then you get a free one. In a variable ratio schedule, we never know when the reward is coming, so we just keep engaging in the behavior. An example that's given here is playing slot machines or fly fishing. We don't get a payout every time we pull the lever on a slot machine, nor do we catch a fish every time we cast out for one. But we keep coming back and we keep trying longer because every once in a while we do get rewarded. An example of a fixed interval schedule that's given here would be if you like to go to a certain store and you know that on a particular day of the week they always have discounts on that day, you may wait until that day to go shopping in that store. An example of an interval, a variable interval schedule is given here is checking your phone for a message. Or we could also say not only for a phone call, but a text message as well, maybe even more so a text message. We never know when we're getting one, but we don't want to miss out on one, and we check our phones often. Just think about how many times you may check your phone in a day. For many people, it's many times a day we'll check our phone to see if we get a message. And they tend to come in a random or variable sort of way. Let's talk about punishment. There are two kinds of punishment, just like there are two kinds of reinforcement. There's positive punishment and there's negative punishment. In positive punishment, some sort of unpleasant stimulus is introduced following an action. As we read here, an aversive stimulus is administered. Examples: spraying water on a barking dog, or getting a traffic ticket for speeding. Has that ever happened to you before? Yeah, me too. In negative punishment, we withdraw a rewarding stimulus. Examples that are given here are taking away a misbehaving teen's driving privileges, or blocking a rude commentator on social media. So we take away something desirable when negative punishment occurs. One area of controversy has to do with the use of physical punishment with children. Is it an effective and helpful disciplinary approach to take to spank children or not? And of course, parents have different opinions and positions on that. Something that you might want to give some thought to and do some reading on that. There's an interesting discussion of it in our textbook chapter. This completes our discussion of operant conditioning. I'd like to move on now and talk with you a bit about cognitive learning. One of the things you probably noticed is that in the case of operant conditioning and classical conditioning, there's really not that much attention given to what's going on in the mind of the learner. The mind is treated somewhat like a black box. There's a stimulus input and a response output. But in cognitive learning, the researcher is interested in what's going on in the mind of the learner. You might be surprised to find out that one of the uh, early studies on cognitive learning was not done with humans. It was actually done with rats. Rats were taught how to find their way to the end of a maze. And one group of rats, every time they got to the end of the maze, they were given a reward. The other group of rats, they just explored the maze for several days without getting a reward in the form of food at the end of the maze. But then with the rats who had just explored the maze but never been rewarded, the very first day that they were rewarded, they could get to the end of the maze after that as fast as the rats who had been learning how to do that every day. So it led the researcher who did this work, Tolman, to conclude that the rats had learned the maze, but they didn't demonstrate it until there was a good reason for them to, and that was to get rewarded at the end of the maze. They wanted to get down there and get that food. Tolman called that latent learning. In other words, latent means hidden, that learning had taken place, but without the experimenter knowing it until the rats were reinforced for getting to the end of the maze. Tolman also believed that the rats developed in their minds what he called cognitive maps, which provided a layout of the maze in their minds. So when they're placed in the maze, they know how to get to the maze lickety split. And of course, we have many cognitive maps in our mind that help us to function in the world. Another kind of cognitive learning is what's called observational learning or modeling. In modeling, we observe someone doing something and then we imitate that behavior. You can probably think of many examples in your life of times in which watching other people doing things helped you to learn various skills like how to drive a car, how to hit a softball or baseball. There's so many different skills that we learn through observational learning. How to be polite, how to be aggressive. I mean, there are so many different things that we might learn through observational learning. Here we see Albert Bandura, the psychologist who did the famous Bobo doll study a number of years back, being awarded the Medal of Science by President Barack Obama for his important contributions to psychology and beyond. And he's probably best known for that famous study he did on observational learning using Bobo dolls. Something else on this slide we might mention before going on and looking at his study is the idea of vicarious reinforcement or punishment. If we're watching someone else doing something and they are rewarded for it, we may be more likely to do it. On the other hand, if they are punished for it, we may be less likely to do it. In Bandura's famous Bobo doll study, he had a group of children watching an adult beating up on a Bobo doll. Another group of children watched an adult being nice to the Bobo doll. And then when he put children in the room with the Bobo doll, those who had observed the adult behaving aggressively towards the Bobo doll were more likely to behave aggressively than those children who observed the adult behaving nicely towards the Bobo doll. this study was a big deal because it showed how children can learn aggression by observing models behaving in that way. It has inspired hundreds and hundreds of studies looking at the importance of observational learning, and even influenced the development of warning, rating systems for movies and video games and things like that. So I would like to ask you to think about ways in which you have been influenced by observational learning in your own life. If you could just think of one or two. I know there are many, because we all are influenced in so many different ways by observational learning. As it turns out, we seem to have specialized neurons in our brain that help us to learn through observation. These neurons are called mirror neurons. They're not without their controversy about some people believing in their presence and importance more than others. But the idea is that when we are watching someone doing something and we can sort of resonate with that activity, that we have neurons in our brain that fire, that help the observational learning process to take place. There's a really fascinating story that's told in your book that occurred in Italy, where these researchers were studying brain activity in monkeys, and they had them hooked up to recording devices. And one day the researchers went out for some lunch, and when they came back into the laboratory, they were eating ice cream cones. And when the monkeys saw them eating ice cream cones, the recordings in their brain of their brain activity started going like crazy, like their brains were very active, in other words, as they were observing the researchers eating ice cream cones. They really weren't expecting to see that. And for them, it helped them eventually to realize we have specialized neurons in our brain that are more likely to fire when we're observing people doing things, especially when we can relate to that activity in some way. And that process may facilitate how observational learning occurs. So it may form the neural, that is the brain basis for imitation and observational learning. This completes our discussion about learning. Thank you.